Welcome to this video on the summer school questions. We're looking here at the three questions that were about the binomial series or binomial expansion, and they're questions 1, 4 and 11. You're encouraged to have a go at the questions first before you watch the solutions. So this is the general formula for the binomial expansion provided in the formula booklet. And we're going to apply it to the expansion of this 3 plus 2x to the power 5, and we're looking for the first three terms. Okay, so we're going to start by recognizing that a is 3, b is 2x, and n is 5. Okay, so here we go. So the first thing to write down is that 3 plus 2x to the power 5, okay, 3 plus 2x to the power 5 is equal to, and we start by writing it out, showing all the necessary steps really. Don't just go straight into the answer, and don't try and carry too much of this stuff in your head. So it's 3 to the power 5, okay, then it's 5c1, okay, 5c1, that's what that means, which of course is 5, and that is multiplied by 3 to the power 4, okay. Now you need to be careful about using brackets where appropriate. I tend to prefer that to multiplication signs, but you can use them, of course, and that's times b, and b is 2x. And the third term would be 5c2, okay, which is 10. Okay, you can get those on the calculator, or you can get them off of Pascal's triangle, of course, and that's 10 times 3 cubed. Okay, so the powers of the first term are descending, and the power of the second term is ascending, so that's now 2x all squared. Okay, and those three are the first three terms, and I just put here plus dot 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 just to show that it does of course carry on, but we're only interested in those three terms. Well, 3 to the power 5 is 243, okay, so 243. Okay, the second term, if you put that in the calculator, you've got 5 times 81 times 2, okay, which is 810x. Okay, and finally the next term is the x squared term. Well, 3 cubed is 27, 10 times 27 is 270, times 2 squared, okay, which is 10,080 x squared. And that's it. And that's all you need to do to get the 4 marks for that question. Okay, and again, you can put that it continues, but you wouldn't need to do that because you were asked in the question just to give the first 3 terms. Okay, so that was question 1. Now, question 4 from the same set of exam questions. I'll just scroll this up a little bit. So question 4, I've just recopied the formula there for our use as given in the formula booklet. So this time we've got to find the first 4 terms in ascending powers of this. Okay, now the first 4 terms will include the x cubed term as well. So it's the number, the x squared, and the x cubed. And again, we just substitute a and b appropriately. This time a is 1 and b is negative 2x. So we have to be careful about the effects of that negative sign. So let's go on with that now. So we've got to start by writing out the original expression, and that is that 1 minus 2x to the power 5 is equal to, now of course with 1 it's quite easy because it's always going to be 1, so it's going to be 1 to the power 5. Okay, the second term is going to be 5c1, which of course is 5, and it's going to be 5 times 1 to the power 4. Okay, now I'm just writing it out here in full just to show what's going on, and that's multiplied by negative 2x. Okay, so that negative sign is obviously important here. And then we go on to the third term, which is 5c3, which is 10. Okay, 5c2, I beg your pardon, which is also 10 in fact. That's 1 cubed, and that has to be multiplied by negative 2x all squared. Okay, now be careful about the brackets and the negative sign there. And the next term, which is the fourth one, as I just said, 5c2 and 5c3 are both equal to 10, as it happens, and that's 1 squared, and it's multiplied by the cube of negative 2x. Okay, so it's just a question now of carefully working those values out. I can put in my additional terms like that. Well, that's obviously going to be 1. The second term works out to be 5. That's all 5 times minus 2, so it's actually minus 10 x. So you could go straight to putting a minus sign here, minus 10x. The third term would be a plus term because you've got your negative 2 squared is 4. Okay, 10 times 4 is 40. The 1 is there, so that's still 40. So it's simply 40x squared. Okay, so it's quite straightforward. And the final term, if you evaluate that, comes to negative 80x cubed. Okay, so that answers the first part of the question, where you had to give the first 4 terms. And you have to give each term in simplest form, which we've done. If x is small, so that x squared and higher powers of x can be ignored, show that this statement here is true. Right, so what we need to do here is basically whenever we see an x squared or higher power, we just ignore it. Okay, we can treat it as very small, and by small it means close to 0. Okay, so it could be 0.1, 0.2 possibly, but more likely 0.01 or something like that, so that when you square it and cube it, it gets even smaller, you see. Okay, now let's work on that. So that was part A, just put that there, and this is part B that we're now looking at. So we have to work out 1 plus x times, okay, and what I'm going to do is simply work out just the first 2 terms out of here, which is 1 minus 10x, okay, because you see, if I include the x squared term as well, then it's already told me that that's too small to worry about, and so I won't need to even look at that. So that's as far as I need to go in the expansion. And when I work that out, I will get, using FOIL, first, outer, inner, last, 1 times 1 is 1. Okay, the outer term gives me minus 10x. Okay, the inner term gives me plus 1x. And the last term would give me minus 10x squared. Okay, and if I were to include any further terms from here in this expansion, it would give me powers higher than x squared, so I'm really not interested in those at all. In fact, I'm not even interested in this one because that's an x squared term. So the only ones I'm left with are, and you've got to be careful now about this, I'm going to put approximately equal to 1 minus 9x, because it's minus 10x plus x, you see, which is minus 9x. And I'm ignoring that because it's too small. So that's the answer. And that's how I've shown it. Okay, and that's question B. And now we move on to the third question from the sheet, which involved the binomial expansion, which was question 11, okay, which I've written down here. So we have to find the first 4 terms in ascending powers of x of the expansion of this. So the same kind of thing that we've already been looking at. It's always made easier if this first term here is 1. But basically we have this. We have that 1 plus ax to the power 10, okay, is equal to 1 to the power of 10, okay, is the first term. The second term is going to be 1 to the power 9. Well, we need to times that by 10c1, which is 10. So it's 10 times 1 to the power 9 times, and then of course it's ax to the power of 1. So it's just ax. Okay. And the second term is 10c2. Okay. 10c2. And we can get these off the calculator, so I can just write down 10c2 there, or use the bracket notation like that, and that's multiplied by 1 to the power of 8, and also by ax all squared. Okay, and don't forget the a squared as well. And the final term is 10c3, okay, using this notation, 1 to the power 7, which you don't really need to write because you know that's going to be 1 every time, and ax cubed, all cubed. Okay, so that's the first 4 terms unsimplified. So we now just put that in the calculator and find the actual values. So it's going to be 1. This is going to be 10 lots of ax. That's the second term. Okay. The third term, when you evaluate it on the calculator, comes to 45 ax all squared. Okay. Or 45a squared x squared. I tend to write it like that without the brackets at this point. And the fourth term from the calculator comes to 120 ax all cubed. So it's 120 a cubed x cubed. Okay, so quite a straightforward process of just substituting and carefully using the calculator. Right, okay, so that answers the first question for 4 marks. That's question A. Now, question B is asking us to find the value of A, given that the coefficient of x cubed is double the coefficient of x squared. Well, that's quite easy. The coefficient of x cubed is 120a cubed. Okay, so we just need to say that 120a cubed is simply equal to 2 lots of the coefficient of x squared, which is 2 lots of 45a squared. Okay, and that's obviously 90 lots of a squared. I'm just writing it like that to show what I'm doing. So basically 120. Now I'm going to divide by a squared as well. So 120a equals 90. But I've divided both sides by a squared. and therefore A is 90 over 120, which is 3/4. Okay, so quite straightforward, that particular question, but show sufficient working to justify your answer in order to get those marks available. And that's the answer to the question. And that's the end of those 3 questions on the use of the binomial expansion. Okay,